All right, welcome to lesson 7.4. In our last lesson, we were looking at the dot product of geometric vectors, and today we're looking at algebraic vectors. So this is when we've got our vectors in component form, and we're on the axes. So for dot products of vectors in component form, once I have them, so not in terms of I, j, and k, we've got them like kind of written as a point. If I have vector u and vector v, then I can find the dot product of those two vectors by multiplying the corresponding components and then adding up those values. It's a nice little shortcut trick. There is a proof of this in your textbook on page 379. And then once I have this formula for finding the dot product of two vectors in component form, I can find the angle between the two vectors by combining the two different dot product formulas. So yesterday we looked at this formula for the dot product of two vectors, which it did involve the angle between two vectors. But if I was given it the two vectors in component form, this is not as helpful. What I can do is reorganize this formula and solve for cos theta, and then I'm going to have the dot product divided by the two magnitudes. So what I've done here is just divided both sides by the magnitudes. But then I would be able to use this form of the dot product formula to come up with my numerator. And then I would divide by the magnitude of each vector. Now, if I wanted to find the magnitude of this vector, this is a position vector, so I know that the tail is at the origin, and this is the point at the head. So to find the magnitude, I just take the square root, and I'm subtracting the components, but I'm subtracting 0 at the origin each time. So I would really just have x1 squared plus y1 squared plus z1 squared. And this would give me the magnitude of vector u. And then I can do a similar thing. I'm going to multiply by the magnitude of vector v. So just multiplication between these two roots and taking the components of vector v and squaring them. All right. So I'm going to use this. It looks like a lot, but really it's a lot of simple arithmetic to help me find my angle theta. All right, let's try an example. So in our first example, we've been given two vectors u and v. We're going to calculate the dot product. So remember our new dot product formula. Normally I wouldn't write it out, but just to refresh, I'm going to take the x values from each vector and multiply them together, and then take the y values from each vector, multiply them together, and then same with the z values, and then finally I'll add up all of those products. So here we're going to have 4 times -1, those are the two x values, and then -2 times 0, and then the z's. And once I have those products, I can just add them up. And so what I've figured out here is that the dot product of these two vectors is -1. The next part here is asking me to determine the angle between them. Now remember that the sign of the dot product already gives me some information about the angle. If I come out with a dot product that is negative, I know that the angle is obtuse, right? So I know that theta is between, not equal to 90, or that would be 0. I know that theta is between these two values. All right, so let's go and figure out my answer. Hopefully it's between 90 or 180, or I made some sort of mistake somewhere. So to come up with the angle, we said that I'll take my formula for the dot product and rearrange it. So it's the dot product divided by the magnitudes. And now I already know the dot product. I'm not going to recalculate it. It's -1. And so what I wish I knew is the magnitude of u and the magnitude of v. So I'm going to come off to the side to do that. But you could do it within this calculation as well if you wanted. The magnitude of u, these are position vectors. So again, when I do the subtraction in the magnitude formula, I'm subtracting 0 from each of the components. So really it's 4 minus 0 is just 4 squared, and then -2 squared, 1 squared. And then we're going to figure out that that comes out to the square root. We've got 16 plus 4 plus 1, so the square root of 21. And then we'll do the same thing for vector v. We need the magnitude of vector v. Again, it's a position vector, so I'm just subtracting 0 from the components, so -1 minus 0 is -1. And so this time I've got 1 plus 0 plus 9, and so I get the square root of 10. And so we're going to substitute these two answers into our formula. And so I've got this expression here. I could simplify the roots a little bit, like I could do a bit of arithmetic here, but really my goal is to solve for theta. So I'm going to get rid of it. Remember, this was cos theta. So to solve for theta, I'm going to bring the cosine over and do cos inverse of this fraction. And you could simplify this as like the square root of 210 if you like, or you can type it in like this. Do practice on your calculator. Different calculators are going to require different things. So maybe you need this set of brackets. Maybe you need a time sign in here. It depends on your calculator. Maybe you need a division sign. Again, it depends on your calculator. So please play around with this, or you could simplify this to the square root of 210 and it'll simplify it a little bit on your calculator. When you type this in, you should get about 94 degrees. It asked me in the question to round to the nearest whole degree, so that's why I have no decimal places. This was part B. Oops. Okay, next example. Before we get into the next example, we need to remember that if I have two non-zero vectors that are perpendicular to each other, right, that's going to tell me that I've got a 90-degree angle, then what do I know about the dot product? I know that the dot product is equal to 0. All right, so in example 2, we're looking at determining the value for k. That's what we want. We're given two vectors and the angle in between them. So the vectors are u, v, and the angle between them is 90 degrees. And there's the k that I need to figure out. It's the y value of vector v. So again, I've got that theta is equal to 90 degrees, or perhaps they could change this question by saying that u and v are perpendicular. Either way, I'm going to start off with what I know, which is that the dot product is equal to 0. All right, so what do I know about the dot product? I know that I can just multiply the x's, the y's, and the z's, and then add them together. So first I'm going to multiply the x's, and then I'm going to add multiplying the y's, and then multiplying the z's. And then we can figure out what this is. We've got here 12, minus plus 2. And so what I have here is negative 2k plus, that's adding, that's plus 14. And then I just have to rearrange and solve for k. So you could go to either side. You could have moved the k over here. And then to isolate k, I'm going to divide out the negative 2. And I get k is equal to 7. So therefore, if theta equals 90 degrees, vector v must be equal to 3, 7, 2. So just something in my k is equal to 7. All right, and have fun with the homework today.